Okay, girls and boys, here we go. Oh, my Lanta, it's going to be one of those days. So we're going to factor, and I think the top factors to y plus 5 times y plus 5. And then I can take a y out and get y plus 3. And then the denominator factors to y plus 3 and y minus 3. And then I get y plus 5. So if I make some ones, I got a y plus 5 and a y plus 5 and a y plus 3 and a y plus 3. So I'm going to get y times y plus 5 over y minus 3. Done. Okay? Yeah. So number 2, I'm going to factor the top. Oh, and I'm going to switch it because it's divide. So I'm going to get 5x plus 2 and 5x minus 2, and then switch x minus 3. And then x minus 3 and x plus 3 and 5x minus 2. So make some ones. I've got 5x minus 2 and 5x minus 2, x minus 3 and x minus 3. So I get left with 5x plus 2 over x plus 3. Okay, and then we get this one. So out of this one, I'm going to factor an a. And if I factor an a, I get a squared minus b squared, which factors to a minus b times a plus b. And then I get 2a plus b and 2a minus b. And then this one flips, so I get a minus 1. So that's my numerator. In the denominator, I'm going to get 2a and a, and b, and they're both pluses, okay? And then this middle one's going to factor to a minus b and a minus b. And then I factor out an a, and I get a plus 1. Okay, so let's make some ones. So the a goes away. A minus b, a plus b, 2a plus b, that should be a 2a minus b, a plus 1. Okay, I think that's it. So I should get 2a minus b times a minus 1 all over all over a minus b times a plus 1. There we go. Done. You don't have to multiply it back out. You can, but you can leave it also this way. Questions? Everyone okay? Ugly factoring, but actually it wasn't too bad. All right, so 6.3, now we're moving on to adding and subtracting. We've done multiplying and dividing. Now we're moving on to adding and subtracting. So how do I add fractions if the denominator is the same? What do I do? Does anyone know? How do I add fractions if the denominator is the same? Yeah, I'm just adding top and bottom, right? The denominator stays the same, and I just add the numerators. So this becomes 5n. When denominator stays the same, just add the numerators, so it becomes 10. And then I simplify that, 2 over n. Okay? Yeah, that's right. 2 over n. As long as the denominator is the same, I'm just going to add or subtract, I guess I should say, my numerators. So number 2, again, my denominator's the same. So I've got x plus y. So I'm going to add my numerators. X plus x is 2x. Negative 3y plus 5y is plus 2y. Now I'm going to see if I can simplify that. So I'm going to factor out what should I factor out? A 2, right? So I factor out a 2 and I get x plus y over x plus y. So my answer should be 2. Yeah, okay. Just so you know, when we add and subtract, they don't always simplify very nicely, okay? Usually only when the denominators are the same. And then number 3, I think, number 3, we have the same denominator. So I'm going to go ahead and factor my denominator now because we may need it to simplify. So I've got a minus 7 and a plus 1. And my top is 5a minus 6a is negative a. And negative 4 minus a minus 11. Negative 4 minus a minus 11 is plus 7. Okay, so I'm going to Sorry, it went down the wrong way. I'm going to factor a negative out of my top. So I factor a negative 1 out, and I get a minus 7 over a minus 7 and a plus 1. So I can make a 1. And I'm going to get negative 1 over a plus 1. Wow. Okay, questions? Are we okay so far? Okay, so I think that you have 4 questions right here. Beautiful. Okay, so let's go ahead and go over this. So remember, if I'm adding them together, I'm going to add my like terms. So let me go ahead and do this also. So I'm going to add my like terms. So those are my a's, and then my negative 4 and my negative 5. So those are my like terms for my numerator. So I'm going to get a plus 5a is 6a, and negative 4b minus 5b is negative 9b over 30a cubed. And then what goes into 6, 9, and 30 is 3, so that would be 2a minus 3b all over 10a cubed. So if I divide everything by 3, I get it simplified. Did that help a little bit? Okay. So same thing on the next one. If you highlight or circle or square, if you don't have a highlighter, you can always go, okay, here's this like term, and then I'm going to underline one, I'm going to circle the other so I know what my like terms are, right? So I've got x minus x is 0, and then negative 6y minus a minus 2y is negative 4y over 10y squared x. So I can divide the numbers by 2. So that'd be negative 2, and the y goes away. 5yx, or xy. It doesn't matter which way you write it. It doesn't matter. Questions? Are you okay with that one?
To get you just divided by 2 and 1.
Yep, I divided by 2. 4 divided by 2 and 10, because 2 goes into both 4 and 10. Yeah. Is that okay? And then there's a y on top and 2 y's in the bottom, so the y on top went away and one of the y's on the bottom went away. Okay? Okay. And then the next one.
Wait, so in B, you didn't have the x's together?
Because x minus x is 0. Yeah. Because I'm subtracting, right? That's a subtract sign. So x minus x is 0. So now I have a plus sign again, so I'm going to just underline and circle my like terms. So I have a plus sign. So a plus a is 2a, and negative 4b plus negative 6b is negative 10b all over 10a squared b. And all three of the terms can be divisible by 2. So I've got a minus 5b divided by 5a squared b. So because all three of them are divisible by 2, I can simplify it. Because there's 3 terms, this one, and this one, and they're all divisible by 2, so I can simplify that one. Okay? But if there's more than one term, they all have to be divisible by the same number. Okay? Okay, and then number 4, again, I've got a subtract sign here. So if my like terms are v, and then the numbers. So v minus v is 0. And negative 4 minus a minus 5 is negative 4 plus 5, so that equals 1 over 6v cubed plus 18v squared. Because this would be written as negative 4 minus a negative 5. Minus a minus is, yeah, so negative 4 plus 5. Because that negative, if you think about that, that negative kind of gets distributed through.
Yeah, it's always like stuff like that makes me
It's the subtract sign that's hurting you, right?
yeah.
Yeah. So think of this as subtract signs. Think of this as in parentheses, and then I have to distribute this negative sign through. Okay? That might help some.
So I never know like whether I should add the extra subtraction sign, like if it's like
A minus is always becomes a plus.
because I like when it's in parentheses and then there's a negative in between it, I'm like, do I just keep the negative or do I change it to a positive?
Yeah, no, it always changes.
Well, that's good to know.
Okay, and now we're going to go to the page. So we're just going to find our least common multiple, which is going to prepare us for adding unlike terms. So our least common multiple is the biggest number. I know we're saying the word least, right? But we want to find the biggest, I want to find the smallest number that they both go into. Okay? Not that goes into both of them, that they both go into. So I'm going to first look at the numbers. So I'm going to do this in 2 different steps. I'm going to look at the numbers first. So I'm going to look at 5 and 8. So what number does both 5 and 8 go into? 40, great. So that number is 40, because both 5 goes into 40 and 8 goes into 40, right? Okay. And then on the variables, I think about this differently because I have y and y cubed, and I need to find a number that both y and y cubed go into. So usually what I do is I find the biggest variable, and that's what it is. The biggest exponent. So in this case, it's y cubed, because y cubed can't go into anything smaller, right? It has to go in, the biggest thing it can go into is itself, which is y cubed. So that's why I choose y cubed. Y can go into y cubed, right? But y cubed cannot go into y. So think of it that way. Okay? So that's kind of how I think about those ones. And then this one is just a little different. This one I need a factor first. Okay? So I'm going to factor both of them. So this first one factors to x minus 3 and x plus 3. And the second factors to x minus 3 and x minus 3. So basically what we're trying to do is find my common denominator. And that's what we did here. Let me zoom back here. This is what we did here, is we found the common denominator between those two numbers, okay? So now we have this big old huge thing that we need to find the common denominator for. So I usually look at it each separately first. So I'm going to look at this one first, and then I'm going to look at this one first, and then I'm going to look at this one second. And if there was a third one and a fourth one, I just look at them each individually. Does that make sense? I know in my common denominator, I need everything that's in here. So I need everything. X minus 3 times x plus 3. So I need that in my common denominator. That has to be there. Then what I'm going to say to myself, I'm going to say, what is in here in my second one that I need in my common denominator? What does this one have? What does this second one have that my common denominator does not have? So what does this one have that this one does not have? There's 2x minus 3s, right? So I need another x minus 3, okay? So if this one has 2x minus 3s, my common denominator has to have 2x minus 3s because it's got to go into it evenly. So this one has to have another x minus 3, and then I'm done, okay? It's got to have, my common denominator's got to have everything that the others have in it, at least one of everything that the others have in it, okay? So it had to have another x minus 3, and that's perfect. Thank you, Paige. Very good. So that's how I find my common denominators, and that's kind of what I think about. It has to have everything that the other ones have in it, okay? So I want you guys to go ahead and try and find your common denominators for A, B, and C. I'm going to talk about this because it looks like a couple people are struggling with the number that they all go into. So, I guess I when I looked at this, I thought, what number does 3, 4, and 6 go into? Well, I know that they all go into 12, right? 3 times 4 is 12, and then 6 goes into 12 twice. So I add then, because there's a 0 on the end of each of them, I added a 0 on the end, so it'd be 120. And then you can take your calculator and find out if it works or not, and it should. Just want to throw that out there. It should work. And then with the variables, I want to find the largest variable and put that there for each one. So I have u to the 6th, and then v squared, and t to the 4th. And there's my least common multiple. That's it. And then for b, I'm going to just, since they're all variables, I'm just going to find the largest of each one of them. So it would be a, b to the 6th, c to the 5th. And then for c, I had to do a little bit of factoring first. So 4, I took a 4 out and I got x squared minus 4. And that become 4 times x minus 2 times x plus 2. And then on the second one, I took a 6 out and got x squared minus 4x plus 4. So that gives me 6 times x minus 2 times x minus 2. So the smallest number that both 4 and 6 goes into is 12. And that's, like I said, I need everything that's in there. So that's x minus 2 and x plus 2. And then for my second one, I need another x minus 2. So you can write it that way, or I can write it as x, I don't know why it's a 4. I'm so sorry. It should be a 2. X plus 2 times x minus 2 squared. You can write it that way also, because I have 2 of those. I don't care which way. Either way. This way, doesn't matter. Okay, questions? Yes, dear.
So for
B.
It's not about adding the exponents, it's just the biggest one?
Right, because I'm not multiplying them together. I'm just finding the least common multiple.
But how do you know when it's time to do that and when you have to factor?
Well, I can't, when I have, like, why I have to factor this one and not these ones? So do you see, there's no add or subtract signs between them. It's all multiplication. This is just all straight multiplication. It's A times B times C. So there's nothing to factor there. And here there's a plus or minus sign. So there's something to factor there. Does that kind of help a little bit? Okay. Okay, so is there any other questions? Those are some good questions too, by the way. Thank you. Okay, so let's go ahead and try and add and subtract now. So we did all that so we can find a common denominator so we can add and subtract our fractions. So for number one, I need to find my common denominator. So first we're going to look at the denominator, which is here, right? This is my denominator. And I want to find the number that they both go into. So what's my common denominator between 15x squared and 5x? 15, what? X squared, right? Just the smallest one that they go into. Okay, so now the next thing I want to ask myself, and this is what you need to do for this, is what do I need to multiply this denominator by to get my common denominator? What do I multiply 15x squared to get 15x squared? What do I multiply it by? 1. So I'm going to multiply both the top and the bottom by 1. Okay? And then what do I multiply 5x by to get 15x squared?
3.
Close. 3 what? I need 15x squared, and I have 5x. 3x. There we go. So I'm going to multiply it by 3x over 3x, right? That's a 1, so it's not really going to change the value of that fraction. It's just going to change the look of it. Okay, so 2 times 1 is 2, plus 3 times 3x is 9x. So my answer is just going to be 9x plus 2 all over 15x squared. If I could simplify it, I would, but I can't, so I won't. Done. When we start getting to unlike denominators, there's not a lot of simplifying. Sometimes I can, sometimes I can't. Okay, most of the times we can't simplify. Especially if we do the least common multiple, there's usually not a lot of simplifying going on. Okay? Questions on that one? Not too bad yet? Okay, let's go to the next one. What's my common multiple between 2x and 2xy? What's my common denominator?
2x.
Close. So, right, I need 2x from the first one, right? What do I need from the second denominator? So what does this one have that this one needs? A y, right. I need the y. Mel, does that make sense? Nice, Jess. Okay, awesome. So now I'm going to ask myself, what do I multiply this fraction by to get 2xy? What do I multiply 2x by to get 2xy? Y. So y over y. Yeah.
I was looking at one that I already did before, so I am ahead.
You're okay. Yeah, that's okay. And what do I multiply 2xy by to get 2xy? 1 over 1. Yeah? So now I multiply my tops together, and I get 2y times y is 2y squared minus 5. And there's my answer. I don't even have to rewrite it to get my variable in the same position. I will, just to make it look nice. 2y squared minus 5 all over 2xy. Questions? You're going to try it now, Tavia. Okay? Okay, go ahead. Try the A and B. I'm going to leave my two problems up there so you guys can see it. There we go. Let's go ahead and do this. So I went ahead and I said this equals 2 times x minus 2. So my common denominator is 2 times x minus 2. Some of you guys might not have needed to do that to realize what your common denominator was and what they shared in common, right? So I'm going to multiply both sides by 2. So on the top, I get 2x plus 2. And then this is a subtract sign. So I'm subtracting that. So I'm minus x plus 1. Because I distribute that negative through, right? So I'm going to get x plus 3 over 2 times x minus 2. And if you multiplied that out, that's great. Also, you could have written 2x minus 4. Didn't matter. Tavia, did you remember to distribute that negative sign? Okay.
It's like when I see the negative sign, I don't see it.
And then a lot of people will just take it to the x and not to the second number too. So they don't distribute it all the way through. That's a common problem. So, okay, so for this one, when I read this, just so you guys know, I read 3n squared on the bottom. So when you guys were putting in your answers, I'm like, what? How did you guys get that? And then I went back and looked, and I was like, oh, that's how you guys got that. So my common denominator is 5n squared. So I'm going to multiply by n squared over n squared. So I should get 3n squared m plus 5. So much easier than what I did. It does not. It doesn't matter. It should probably be mn squared since you write them normally in alphabetical order. But it doesn't matter what order you multiply things in.
Well, I just thought maybe because it was 3 of them already together.
Yeah. Yeah, you could have written it as 3mn squared plus 5 over 5n squared. It doesn't matter. Either one is correct, okay? Or, let me put an or in there, okay? All right, so just getting a little teeny bit harder, although they're not really in that good of order anyways, but, you know, I did the best I could. So my common denominator, this 4 has a denominator of 1. It does have a denominator. My denominator is 1, right? So my common denominator between the two fractions would be x plus 1. So this first fraction needs an x plus 1 in it. So I distribute the 4 through there, and I'm going to get 4x plus 4 plus x minus 3. And I should get 5x plus 1 over x plus 1.
So you don't always have to multiply both sides by anything?
No, because this one I'd just be multiplying by 1. And that's just the same thing, right? Okay. Yep, a lot of the ones that we've been doing, we've only been multiplying by one of them by 1, so.
So like when you get harder stuff, like
You'll be multiplying both sides by, yeah. Okay, so like this one. Okay, so good lead in there. So this one has two different common denominators. Not two different common. It has one common denominator, and my common denominator. I'm gonna factor this just because I think it factors out later. So it's a minus 3. I think that's right. 3a. Factor out of 3a, yeah, okay. And actually we can make this fraction, we can make all this simpler by simplifying this one fraction right now. I'm just gonna say this, right? If I can simplify the fractions before I add them together, you should do that. So I should get this problem down to be, because I have a 3a in my numerator and a negative a minus 3 in my denominator, I can get this and simplify it down to be 5a divided by 2 minus, not equals, minus 1 over 3a. Much easier and much simpler fraction, right, to add. So now my common denominator becomes, what is my common denominator? 6a. So I'm going to multiply this one by 3a and this one by 2. And I'm going to get 15a squared minus 2. Done. It was much easier multiplication. And I didn't have to simplify later. That was much easier. Okay, 2 more problems for you guys to try. Is there any questions so far? Are you guys doing okay? Everyone in class? Jada, Serena? Which one?
It's like, I know, like the process of getting it, why you, sort of simplified earlier, but, like, how did you get the numbers?
How did I get these numbers down here?
No,
These ones?
yeah.
So, okay, so let me just come over here. So I have 3a squared minus 9a, right? What goes into both 3 and 9? 3, so I can take that out. And what goes into a squared and a? Well, an a. Okay, so basically I'm unmultiplying. So if I take a 3a out of 3a squared, what do I get left with? A. And now think about if I multiply it back out, 3a times a is 3a squared. And then if I take a 3 out of 9, that leaves me with a 3. So if I distribute this back out, I should get this answer right here. That's what I want to make sure. So I'm unmultiplying or undistributing. Does that help a little bit? Yeah. So if you think about it that way, I always feel that helps me think about it because I know if I have to multiply it back out, I should get exactly the same thing. So if I just do a real quick check and say multiply it back out, if I don't get the same thing, I know I did it wrong. Does that help a little bit? Okay, awesome. Okay, so let's go ahead and I'm going to do both of them. Okay, so for A, my common denominator is going to be 5 times 2v minus 1. So I'm going to multiply this one by 5 and this one by 2v minus 1. So I'm going to get 5v minus 15 plus 12v minus 6. So I'm going to get, I know I wrote that really teeny, sorry. 17v minus 21 over 5 times 2v minus 1. Okay? Beautiful. Questions on that one? Are we okay? All right. So number B, my common denominator is going to be x minus 4 times 3x minus 5. So I'm going to multiply this one by 3x minus 5. And I'm going to multiply this one by x minus 4. So I get 15x minus 25 minus 3x plus 12, because this is a negative 3. So then I get 12x minus 13 all over x minus 4 times 3x minus 5. Questions? Does that make sense? Okay. It's all this minus sign. Don't forget it. So when I'm multiplying this minus sign through and I have a number, I just think of that as the negative number. So instead of 3, I think of it as negative 3, and I distribute a negative 3 through. Okay? And then you just add your terms together. Is that okay? Okay, how are we doing on time? We're doing okay. I'm just gonna look, okay. So here we go. So I'm gonna factor this bottom one here. So I get x minus y and x plus y. Okay, so now my common denominator is x minus y and x plus y. And this one needs an x plus y. Okay, so I've got, what do I have? what do I have? 6xy minus x plus y times x plus y. So glad I gave myself lots of room to write. So in my numerator, I got 6xy minus x times x is x squared, plus xy plus xy plus y squared. Okay, beautiful. All over x minus y, x plus y. Questions so far? Do you know how I got those numbers? Letters? Whatever. Whatever you want to call them. They're letters, right? I just distributed this, right? Okay, so I distributed this.
You simplify.
I FOILed it, yeah. So I multiplied that out. Now I'm going to distribute the negative through. So I've got 6xy minus x squared minus xy minus xy minus y squared all over x minus y, x plus y. And now I'm going to combine my like terms, okay? So I'm going to end up with negative x squared plus 4xy minus y squared all over x minus y times x plus y. And that's it. Can't simplify it any further than that. There's no way I can do 1 and 1 and get 4. Okay, yeah. That is correct. They do get more complicated, right? As you can see.
Everything is now.
Yeah. It's actually not even more, it's just more math. And it's just easy math, right? I'm just multiplying and adding like terms, right? Okay. It's just a lot more terms, right? Okay. Oh,
Adding on.
yeah. Oh, my Lanta. Okay, so if I factored this, I'm going to get 30 is 6 and 5. Is that right? X plus 5. Someone's like, yes, it is. And then 20 is 5 and 4. X plus 5 and x plus 4. So I'm going to write my common denominator. Yeah, I can write it over here. I'm good. That should give me enough room. So I need x plus 5 and x plus 6. And what do I need from this denominator? Do I need the x plus 5?
Well, can you square the x?
I already have an x plus 5. I don't need another one.
So then
Just the x plus 4, yeah. I would need another one if there was 2 x plus 5s in that one. Does that make sense? But since I already have one x plus 5, I don't need another one. Okay? Good. So what is this denominator missing? That my common denominator has?
Which one are you thinking?
The one with this one right here. What is my first denominator missing that my common denominator has? That's really ugly. X plus 4, right? So that means I'm going to take x and multiply by x plus 4, right? I need to multiply by x plus 4. And what is my second denominator? What is my second denominator missing that my common denominator has? X plus 6, right? Minus 5 times x plus 6. Whew, okay. Wow, that's not going to be that bad. I thought it was going to be a lot worse. Okay, so we've got x squared plus 4x minus 5x minus 30 all over x plus 5 times x plus 6 times x plus 4. And this simplifies to x squared minus x minus 30 all over, oh my Lanta, x plus 5 times x plus, this is the long part, is having to write it all out. X plus 4. I wonder if that factors. What What multiplies to be negative 30 and adds to be negative 1? Oh, negative 6 and 5. So it does factor. So x minus 6 and x plus 5. X plus 5 times x plus 6 times x plus 4. So I have an x plus 5 and an x plus 5. So my answer is going to be x minus 6 over x plus 6 and x plus 4. Done. Holy moly.
Is there a way that you can get like the simplified and denominator earlier?
I know. I was just thinking that too. But no, there's not. Like in the other ones I could, because I could simplify them. You know, that one I could just simplify really nice. This one doesn't simplify. That's already as simple. The starting point is already as simplified as it can get. So you guys, yeah, let's go ahead and work on. I don't know if we're going to get them all done today. So I'm going to say this. We're going to do as many as we can today. Let's go ahead and do this problem here. So my common denominator, let's make it a little bigger. My common denominator, I said my common denominator was 5n minus 6 over n plus 5. So that means this one needs an n plus 5, right? And this side needs a 5n minus 6 to look like my common denominator, right? So I'm going to distribute the 6n through, and the negative 4, that's a negative 4 because it's a minus, through. So 6n times n is 6n squared, and 6n times 5 is 30n. Negative 4 times 5 is negative 20n. And negative 4 times negative 6 is positive 24. So that gives me 6n squared plus 10n plus 12 all over 5n minus 6 times n plus 6. I'm just going to see if I can factor this. So I'm going to factor 2 out, and that will give me 3n squared plus 5n plus 6 all over 5n minus 6 times n plus 6. So I get a 3 and a... So what factors to be 6? 3 and 2. So 3 and 3 is 9. 2 does not make 5. I need to add, what needs to add to be 5? I don't think that's going to work. 3 and 2 is 6. Plus 3 is 9. Yeah, no. So that's as far as it can go right there. Okay? Awesome sauce. And then, any questions on that one? Are we okay? Okay. So number B, they don't have anything in common. So that means my common denominator is going to be 2x plus 5 times x minus 5. And this side needs an x minus 5. And this side needs a 2x plus 5. And then I distribute and I get, let's see, what is that? 4x minus 20 plus 8x plus 20. Yeah, that's right. Yeah, okay. So that's going to equal 12x over 2x plus 5 times x minus 5. Done. Okay, questions? All right, and then the last one on this page. Woo. Okay, so if I factored this, I get an x plus 2 and an x minus 2. So I think I have lots of room down here. So my common denominator, I'm pretty sure, is going to be x plus 2 and x minus 2. So this one needs an x minus 2. And this one needs an x plus 2. And the third one doesn't need anything. Awesome. So if I distribute, I should get negative 2x plus 4 plus 5x plus 10 plus x plus 3. Combine like terms. That's 3x, 4x. 4 plus 10 is 14, plus 3 is 17. All over x plus 2 times x minus 2. Questions? Yeah.
I get how you factored the third one, but then wouldn't there be a second set of x plus 2 and x minus 2 done on the denominator?
No, because, so I'm going to take everything, so this is how I thought about it. Let me highlight. I'm going to take both of these and put them down in my common denominator, right? Is there, and then this one's already there, right? So I already have an x minus 2 there, right?
Yeah.
And I already have an x plus 2 right there, so I don't need to add anything else. If this one said, let me write this. If this one said, x minus 2 squared, and I needed 2x plus 2s, then I would add an extra 1. Does that make sense?
Yeah.
But because it only has 1, and there's already 1 in my denominator, I don't have to add another 1.
Okay.
If there's already 1 there, I don't have to add another 1.
Okay.
Does that make sense? Okay. Okay. All right. Okay, let's go to the next page. So now we're going to talk about kind of like what we did when we were doing multiplying, dividing, right? So now we have a complex fraction. And all a complex fraction is, you guys, it's a fraction divided by a fraction, which we talked about when we were doing multiplying and dividing, right? So we have a fraction dividing by a fraction. So what I need to do for them is I need to treat them first like two separate problems. So I'm going to do the top first. So I'm going to do this one first, and then I'm going to do this one, and then I'm going to treat it like a divide problem, right? So I'm going to get the top done, and then I want to get the bottom done and get them all down to one fraction in the top and one fraction in the bottom, and then I'll divide it. Okay? So I'm going to do the top only right now, so I'm just going to work on the top. My common denominator for the top is x. Ooh, okay, so this one needs an x because it's 1 over 1. So that should be x plus 1. Whew, okay, wow. And my common denominator in the denominator, wow. My common denominator in the denominator is x squared. That can get a little confusing, right? So it needs an x squared. So this one should be x squared minus 1. So now I have a fraction divided by a fraction. How do I divide fractions? Does anyone remember? What do I do? Reciprocal of which one? The second one, or the bottom one, right? So I'm going to take the reciprocal of the bottom one. In case you don't remember what a reciprocal is, it's when I take the top and the bottom and I flip them, right? So I just flip the fraction and it becomes times. So this whole problem becomes x plus 1 divided by x times x squared all over x minus 1 squared, which factors to x plus 1 and x minus 1. I might as well factor while I flip, right? So I'm going to flip this one and factor. So then I've got, can I make any ones? Well, yeah, I can do the x plus 1 and 1x on the bottom and 1x on the top. So my whole answer should be, what should my answer be? X over x minus 1. Okay. I don't know why I decided to go out instead of down. I just did. So it doesn't matter which way you do it, right? I can go horizontally or I can go vertically. When I'm solving my problem, it doesn't matter. Okay, so let's see how you guys do on A and B. And then, okay, so I did the top first. And I said my common denominator is 3x. So I need to multiply by 3 over 3 here. So I got 6 minus 2, or 4 over 3x. And then in the bottom, My common denominator is 6x, so I need to multiply by 6 over 6. So I got 6 minus 5, which is 1 over 6x. So then I get 4 divided by 3x times 6x over 1. 3x goes into 6x 2 times, which equals 8. Questions? Tavi, are you okay with that?
Yeah, I just get confused in trying to find the common denominator.
So I'm just going to look at these two numbers. I need to find out the number that they both go into, right? So what number does both x and 3x go into?
3x.
Yeah. Yeah. So if I'm looking at like B, if I look at B, and here's my common denominator, see, they don't have anything in common, so it needs to be both of them. But here, these ones had the x in common, so I don't need I could have the x there, and then it needed the 3, so it became 3x. So think about what do they have in common and put that there first, and then whatever's left over they also need. Does that help a little bit?
Yeah.
Okay. Okay, I need the pen, not the highlighter. So for B, I think I'm going to do it down here this time. So my common denominator on this one for the numerator is going to be x minus 1 times x plus 2, right? So this first one needs the x plus 2, and this second one needs the x minus 1. And then I distribute, right? Or you can do your box. It doesn't matter. I distribute the x through, and then the 2 through, and then the x through, and the negative 1, right? I FOIL, right? Or you can do the box. I don't care how you multiply it out, but I've got to multiply it out. So I've got x squared plus 2x plus 1x plus 2 minus, my line needs to be longer, x squared minus 1x plus 1. There we go. So now I need to simplify that. So on the top, x squared minus x squared is 0. 3x minus a minus is all plus. So 3, 4, 5x. And 2 minus 1 is 1. There we go. All over x minus 1 times x plus 2. All divided by, I can take a 3 out. So 3 times 5x plus 1 all over x plus 1 times x minus 1. So it's a divide problem. So I want to flip this one and turn it into a times problem. So I'm going to get 5x plus 1 over x minus 1 times x plus 2 times x plus 1, x minus 1, all over 3 times 5x plus 1. Whew. So if I'm going to make ones, I've got a 5x plus 1, x minus 1, and then what I'm left with is x plus 1 over 3 times x plus 2. Okay, longer problem. It just involves two things that we've done before. It doesn't make it any harder than what we've done. It just looks like it is because it looks complicated, right? But it's just two things we've done in the past put together in one problem.